Hello, everyone, and welcome to today's SANS webcast. Your current approach to threat detection and neutralization is broken. Sponsored by ThreatX. My name is Carol Auth of the SANS Institute, and I'll be moderating today's webcast. Today's featured speakers are John Pescatori, SANS Director of Emerging Security Trends, and Brett Settle, CEO and co-founder of ThreatX. If during the webcast you have any questions for our presenters, please enter them into the questions window located on the GoToWebinar interface at any time. Please note that this webcast is being recorded, and a copy of the slides and recording of this webcast will be available for viewing later today and can be found on the SANS registration page. And with that, I'd like to hand the webcast over to John.
Thanks, Carol, and welcome everyone. I'm John Pescatori. This is a very famous date in history, the 6th of June. This is known as D-Day, where the Allied forces back in World War II began the decisive battles by landing in Normandy and driving back Hitler and the aggressors. And I think that's a great time to sort of launch a discussion about rallying the troops to stop the attacks against our web applications, our businesses' data, and our customers' data. And that's what we're going to focus here today. Let me give you an idea of what we're going to go through. I'll start by doing sort of a 50,000-foot overview and then narrowing down into this particular area of web application security. And I'm going to give you some of the perspective I've had in following and analyzing this area for close to 20 years now, and show you some data from some of the latest threat reports out there. Then I'm going to turn things over to Brett Settle from ThreatX. They'll give you their viewpoint and do a demonstration of ways you can use their products and services and what it looks like protecting applications using their techniques. We'll have plenty of time at the end for questions, but to echo what Carol said, as we go along, if you have a question, especially during the demo, you can enter it into that window on the right-hand side. We might be able to get to some of the questions as we're going along. If not, we'll definitely get to them at the end. If you are watching the recorded version of this, at the very end, we'll give you an email address that you can send questions in, and we'll get the answers back to you as soon as possible. So with that, let's get started. So one of my jobs here at SANS, I've now been here at SANS for, well, getting close to 6 years after almost 14 years at Gartner. One of my jobs I get to do is to sort of keep up on the latest threat and vulnerability reports that are put out there by a wide variety of players. And one of the bigger ones each year is the Verizon Data Breach Investigation Report. It's a little unique in that it's based on investigations by Verizon and their partners, consulting engagements after incidents, after breaches or other types of security incidents. So the data is about how things happened versus just sort of what quantity of things are being launched out there. You know, it's sort of like nobody cares how many billions of raindrops fell on your house overnight. You really only care how did the water get in that caused the leak and how do I stop that? And that's what the VBIR is good for. So on your screen, I took their summary data, and I'll just point out what to me were some of the more interesting numbers. Sort of in the upper left there, you can see about 50% of breaches were carried out by organized crime groups. If you read the news, you'd think everything was nation-state oriented these days, because that's certainly top of mind for the press and capturing the most column inches. But if you also look in the lower left, you see 76% of breaches were financially motivated. So the reality is, for most businesses out there, the most likely damage-causing event you're going to see is going to be launched by a criminal group looking to make money, typically by stealing personally identifiable information that's used for new account fraud or direct financial fraud, or just resold online for those purposes. Some of the other interesting data, if you look down at the bottom left, who are the victims, we've seen a big uptick in the past, really the past 2 years, in healthcare being the most commonly breached vertical. There's a lot of reasons for that. I mean, one is financial and retail have been in the crosshairs and raised the bar a little bit in their protections and fraud detection and protection of their applications and their people. And healthcare has been slow to move, so the attackers go for the easy targets. Also, they found that a lot of personal identifiable information in healthcare records that can be used for new account fraud. They don't need credit card numbers to make money in this world. But there's some other interesting data sort of scattered about out here. If you look at the upper right, you see, what's that say, 48% of the breaches featured hacking. Now, I'll show you some other data, and certainly there's a concerted attempt out there through phishing attacks and other things to trick users into giving up their credentials or other ways of, getting screen scraping software on users' machines to steal their credentials and like. And that certainly gets a lot of press and a lot of focus. But good old-fashioned hacking of our applications and our servers and everything else is still alive and well and being very successful. And I'll show you some more data on that in another slide. But the key takeaway is, the other one I want to point out here at the lower, lower left, 58% of victims are categorized as small businesses. The reality is, doesn't matter if you're a tiny business, doesn't matter if you're in some sleepy vertical. If you've got vulnerable applications and vulnerable exposures on the internet, they're going to go after you because they're going after everybody. What we're seeing here is the percentage that's succeeding, and the goal is to not be part of those, to be part of the percentage that the bad guys bounce off and they move on to somebody else. Now, they show some little more detailed data here. On the left-hand side, you see the data from overall security incidents, sort of everything they investigated. On the right, it's breaches in particular. But if you look on the left-hand side, you see number one is denial of service through hacking. Now, that covers a variety of sins. Denial of service can be straightforward, sort of brute force flooding of your website. That's sort of gone down over the past couple of years. A lot of it is sort of application level attacks that are looking to cause web apps to go into resource consumption and just sort of cause the whole website to ground to a halt, to take advantage of weaknesses in the application or badly coded features and the like to do that, or other things like ransomware, where executables are encrypted can be counted as application level DOSing. And if you look down the list through incidents, you see in parentheses hacking showing up quite a bit. I just want to keep pointing that out, that it's not just only phishing that's out there. And in fact, on the incident side, you see the use of stolen credentials through hacking is number one on the breach side of the list. So quite often our users are getting a little more suspicious about giving away their username, password in response to an email, but they do have a tendency to click on links and go to websites. So if the bad guys have compromised the website and installed credential capture or logical equivalent of screen scraping there, they're capturing user accounts there, or they're going directly against databases and able to use a lot of password and other Rainbow and other type tools, dictionary type tools to capture user passwords and login accounts from those vulnerable servers. So, once again, protecting those applications is key. And on another chart I always like to look at, although they've changed this one a little bit over the years, you can see this shows you by verticals across the top. And then on the left-hand side, they list different patterns or different sort of attack techniques. For example, you see crimeware number one on the top there. It's listed in alphabetical order and denial of service. And you see the specific actions that were done if it was error and environmental cause or hacking and so on. And then finally at the bottom, the type of assets that were attacked. And you can pretty much see which vertical you're in. You can kind of see what the most common thing happened to you. I mean, some are no surprise. For example, in the past year, we've seen nothing but press reports about hotel chains getting broken into through point-of-sale weaknesses on credit card swiping. So you see that's the number one incident under accommodations and so on. But a couple things, again, you can see in the middle bar there under actions, hacking is well represented across all verticals. And if you look down at the bottom, the asset servers, other than directly attacking the general public, servers are what they're attacking. That's where the biggest chunks of personally identifiable information or financial data, or for industrial or nation-state sponsored espionage, where the sensitive information is stored. So again, I want to keep that in mind. And obviously today, when we start thinking about protecting our applications and servers, we're talking about protecting web-based or web front-ended applications and servers, and what we can do about that, in particular, how we can improve the security there. So I'm seeing a lag here. I don't know if somebody can advance the screen, because I can't advance it right now. There we go. So I joined Gartner in 1999 and spent about the next 14 years there as the lead security analyst. And one of the early areas I jumped on in 2000 was this area of protecting web applications. We were just starting to see the explosion of commerce and web front ends as the ability for consumers and even B2B to get to applications. So I put together a note back then. You see a graphic up on your screen from the hierarchy of securing web servers. And at the bottom were the easiest things to do, lowest levels of security, but also lowest levels of cost. And going upwards were the ones that provided more security value, but were harder. And at the bottom, obviously, you know, the old segmentation and DMZ, have a standard firewall in front of your web servers and apply security checklists. Like even back then, the Center for Internet Security had a good set of configuration checklists. Then do a lot of detection, but network and host-based, and turn on policy enforcement on the operating system if it was Windows or Linux. And then you see this thing, application-specific firewalling. This idea of a thing called a web app firewall really didn't exist at that time, but we were starting to see the need to go beyond the standard sort of port protocol protection a standard network firewall gave you, and the ability to do some very application specific, or in reality at those days, protocol specific security protections to stop attacks that were trying to come through HTTP essentially and attack the servers. And any of you who are old enough to remember, back in, what's that, 17 years ago now, HPUX and Solaris and even a version of Unix, there were secure versions, called Orange Book versions of these operating systems that had been pared down to be these trusted operating systems or web server, high security appliances that were being used by banks and the like. So we put those as sort of the most highest level of protection, but immensely expensive, and they never really worked out. Next slide, please. So about 7 years later or so, the problems are still there. By then, I talked Neil McDonald into moving from the network side of Gartner over to the security side, and he joined me in on sort of an update of this note. And you see it looks very similar, moved things around, made securing configuration standards for the operating system, the web app, and all the other helper apps, you know, these days the WordPresses and Joomlas of the world on there, very key as the minimal levels of protection. Everybody should do that, or trying to add the higher levels is hopeless. Then, by then we'd come up with this term web application firewall, and the idea that there were two things you could do. You could make sure your applications didn't have vulnerabilities through application vulnerability testing and fixing the applications, that's 3A, or what it turned out, most companies, it was very hard to get the app dev people to change their ways and achieve secure applications. So the idea of a web application firewall that could provide mitigation in front of vulnerable applications became sort of the due diligence level of security. And certainly when the payment card industry started specifying WAFs by name, became sort of a compliance item as well. And then the idea that if you want to go beyond that and put some host-based software on those servers, you could go beyond that. And then you see the asterisks. There are still a few companies in 2008 using these very high-end trusted appliances. I managed to get that one to go that time. I say if that was really me clicking. Now, I left Gartner in 2013, but you see here in 2017, they were still putting out some similar notes protecting web applications, and the world's gotten a lot more complex. A lot more elements involved between the client and the server and the data, different APIs and different pieces from transport security to the attack security and the authentication, other things that are going on, and other types of applets and web APIs and web services and things involved. But you notice still up there in the top, you see, even if you're using an app delivery controller or a content delivery network, you know, the idea of web application firewalls playing key roles in protecting things at different levels is still very important and showing up in the Gartner research these days. So next slide. I guess that wasn't me the last time. I mentioned the Center for Internet Security early on. Back in the old days when I was at Gartner, they were putting together some really, what they called benchmarks, really good guidelines for how common things should be configured. A Windows server, an Oracle database, a Netscape web server, a Microsoft IIS server, you know, whatever. Right about that same time, in the late 90s, 1998, at the National Security Agency, an effort started up to say, what are the security controls that provide the largest obstacles to the bad guys launching the attacks they are commonly launching. And NSA, what they did is go to their own pen testers and say, when you can't get in somewhere, what's keeping you out? What security controls are most effective? And to blue teamers, defenders, what security controls have you found most effective in keeping the bad guys out? That became known as the critical security controls, and SANS supported it for many years. And 2 years ago, we transferred it over to the Center for Internet Security as a nonprofit organization that was also doing the benchmarks. And they just recently came out with version 7 of the updated controls. And at the end, I'll give you a URL so you can get the latest information from them. They made a few changes this year. They sort of split them out into 3 large categories. The basic ones, which you see in blue there on the left-hand side of the right-hand side of the screen. And those have the basics of knowing what hardware and software is running on your network and what applications and what vulnerabilities they have, and doing some of the very effective things like privilege management and application control and monitoring of logs and the like that pretty much form the foundation for the basics of any security program. Then you see the foundational ones, which sort of add that next level, sort of like if you're building a secure house or a secure building, all the things you'd want to add. And then organizational is where some of the ones that were more process involved got moved to this past year in version 7. And that's where you see application security because of those 2 pieces. There's the protection piece we can do with the web app firewall. There's also this desire to see if we can move to a secure development lifecycle and get the underlying software to be more secure. So for that reason, in version 7 here, CIS moved those things into that organizational bucket where you see other things like pen testing and education and incident response and some very key processes. So if we go to the next slide, there's a little drill down on the CIS control where application security falls. And this is their little state diagram they show where, of course, on the right-hand side are the computing systems, and on the left-hand side are where you see all the reporting, and in between are the security controls. So there's the ones you see up on the top, the coding standards. Hopefully you can get your developers to build code more securely, educating the developers and the users, using code analysis systems to test the code before it goes production. And those are all good and valuable things. However, they're also very hard to do. So we find that most organizations over time have said, as we're working to try to get to a secure development lifecycle and drastically reduce the number of attackable vulnerabilities in our code, we still need web application firewalls at the front end to shield the ones where vulnerabilities are still appearing, or in areas where our SDLC processes, our tools, or testing techniques don't know about this new type of vulnerability that's been discovered. Or actually what in reality happens way, way too much is where insecure versions of apps are restored. That's, you see a lot of WordPress and Joomla things getting attacked these days because an unpatched version got put back in when something got restored or additional capacity was brought up. So if you remember back to the Verizon slides at the beginning, error and misconfiguration are always a big part of the vulnerabilities that attackers are able to exploit, and we need ways to shield and mitigate. Put something in between those misconfigured or unknowingly made vulnerable type systems, and the attackers are scanning around looking for those vulnerable systems and then very quickly launching attacks against them. So that's an overview, sort of drilling down on this area of web security. Let me now turn it over to Brett from ThreatX and have him go drill down. Got to go to the other way. Go drill down. Over to you, Brett.
Okay, thank you, John. A little history maybe on ThreatX, because I can echo a lot of what John talked about. But prior to starting ThreatX, my co-founder, Andrew Yusekis, and I were working at BMC Software. And at that point in time, they were looking to really overhaul their security infrastructure. And we spent millions of dollars on a lot of the best of breed solutions. Some of the key vendors in next-gen firewalls, WAF, SIM, you can kind of name it. But what we found is we were fairly underwhelmed just simply with the fact that most of the tool sets out there were looking at single transactions, and they were generating a tremendous amount of both false positives, but also just the maintenance burden that it took to interpret the results, review the logs, and try to understand whether or not the solutions were actually working. So in 2015, we left BMC Software, started ThreatX, and began building a solution that is comprised, and I'll get to it in a second on the diagram, but comprised primarily of a behavioral analytics engine that's being fed by multiple types of sensors. And the net result is we're able to take more of an attack-centric view. We're looking to look at individual users, or what we would call entities, and then track their progression as they interact with the applications, identifying the various steps that they're taking through the kill chain, and then developing a risk scorecard that allows us to have much more clarity about who should be blocked, as well as what parts of the applications are they actually targeting. So over the last couple of years, we've really been hardening the solution. Again, coming from large enterprise world, we knew that we needed a solution that could work across multiple types of environments, but also, it's very critical not to have a solution that will cause outages on production applications. And so we worked very hard to make sure that both the accuracy of the detection engine is there, but also the support and scalability are there as well. To break down kind of what we do, it's a SaaS-based application firewall. It's built based on Docker containers. And so the primary technology, the sensors themselves, are Docker containers that can be deployed in virtually any environment. This gives us the flexibility to route customers' traffics through our network and do the processing and then send clean traffic back to their applications. Or it allows us to deploy containers in the customer's environment, be that on-premise, be that in AWS, Azure, or virtually anywhere that they have their applications. It's a container, so it can be loaded with the applications. It can also be used as a plug-in. For example, Nginx plugin is a great implementation for the solution. But in order for us to be able to provide this capability, we needed to have not just web application firewall type protection, but we also needed to be able to provide some of the table stakes that are out there. So being able to provide DDoS protection, provide accelerated content delivery or edge caching, along with load balancing that goes with that. Part of what we'll talk through as we go through the demo and as I talk through the architecture is a very advanced botnet detection and management capability. And then ultimately from our customers, as we continue to roll this out to our initial beta customers, one theme kept popping up, and that was the traditional, we don't have enough resources, but more importantly, we don't have enough resources that really understand layer 7 and the types of attacks that are going on against a wide array of application technologies. And so we were more or less brought into the managed services business by our customers because we had a lot of good information as we saw the attacks across multiple types of technologies, but also across multiple customers. And therefore, we were able to quickly identify not only the techniques that were being used, but also help our customers identify the proper mitigation to those attacks. And we'll see that as we go through the demo. Just quickly, and this will be the last slide before I do jump in the demo, but to give you a sense of kind of how the ThreatX platform works, what you'll see is in the center is really the containers that house our sensors. And part of the sensor strategy is to have both DDoS protection, the sentries, where we can provide either on-demand up to 50 gigabit or always-on DDoS protection. We have an active deception component, and really what this is doing primarily is injection. We can inject cookies, we can inject JavaScript, we can inject false URIs, headers, and responses. The key here is it's very interactive, and what we're trying to do with this is, go beyond just the standard honeypots, but actually layer on top of customer applications false components that allow us to get the bad guys to tip their hand as to whether or not they're there or not. From a malicious profiling, we also use the injection for both botnet detection, but also IP fingerprinting. And what I mean by that is we're doing similar techniques to what you'll see with marketing sensors. We're identifying things such as browser information, cookie information, everything down to the fonts that are installed, language codes, screen resolutions. And again, the key for that is a lot of the more advanced attacks are coming, as you guys know, from multiple IPs. And so what we are attempting to do is pull information based on either knowing that it's a fingerprint match or knowing that the fingerprint is close enough that we can watch their behavior. But it allows us to go back then and construct, correlate, and analyze the data across attacks that are jumping from IP to IP. And then lastly, the anomaly detection component is it's dynamic application profiling. So monitoring what are normal inputs, what are normal outputs, what are normal responses or error conditions for the applications. There's a bit of machine learning in there and behavioral analysis, but the key is it allows us to move very quickly, dynamically profiling the applications. And this becomes especially important because of the dynamic nature of application enhancements and rollout. We're able to use the profiling to very quickly, within 24 hours, identify changes as applications are released with new changes built in. The sensors themselves then interact with the decision engine that's local to the containers. So this decision engine has its own list of known threat entities. Again, not so much a blacklist, but a list of entities and relative risk that we're seeing across all customers on all applications. It also includes the known threat behaviors. What are the techniques that they're using? And what is the process or sequence they use as they work their way through the kill chain? The decision engine then does the correlation of the events for that particular user, performs a risk analysis, and creates dynamic rules on the fly. And ultimately, this is so we can get to the point where we can provide both active blocking as well as blacklist, whitelist. Targeting, which for us is a form of almost rate limiting. It's the ability for us to slow down the responses, especially for someone who we suspect is either a botnet or is malicious intent. And then interrogation is a way for us to, for someone who we feel is suspicious and we need to gather more information, again, engage in more deep level of active deception, where we're interacting with them to identify more suspicious behavior. All this information, again, can be deployed either in our network or can be deployed in the customer's hybrid cloud environment. The metadata is passed back to a threat analysis platform, and this is where we really go across customers, across applications, and start identifying the trends and the behaviors that we're seeing from a shared threat analytics perspective. There's also a component which is utilize big data to identify suspicious but not yet confirmed type of activities. Great for both zero-day type of activities, but also just net new capabilities that our solution has not picked up yet. And in these cases, we'll use advanced visualization, and our SOC will engage to do additional investigation, and then ultimately update the threats or the behaviors. Now, all of this information is relayed to our customers so that at any point in time, they can see in real time the threat response platform. They'll get to see the list of all suspicious entities, the risk that's been assigned, which ones have been blocked, and then you're able to drill into the details underlying those blocks or those certain risk conditions so you can understand why they were blocked as well as what they were targeting. So when you first log into the ThreatX platform, what you're going to get is a live view, and this is showing you updates every 15 seconds in terms of the overall attack posture. On the left-hand side, you'll get just a basic indicator that says on a 0 to 10-point scale, what's the average threat or risk score during the last hour. It defaults in at 2 hours. You can see between 2 hours up to 24 hours. And again, what you're getting is a graphical representation of just the attack vectors and the overall risk at any point in time over the 24-hour period. I'm going to back it up to at least 2 hours in the beginning so we can walk through some of the metrics below. In this case, what you're seeing is 44,000, almost 45,000 total requests. 116 of those page requests were actually suspicious. We've done the correlation and analysis behind the scenes to boil that down to 66 unique entities. And then of those, 7 were blocked. We've got 296 blocked requests during this period of time. And then a quick reference to if we blacklisted or whitelisted, and I'll talk about that a little bit more. The map is just a quick reference for where the attacks are coming from, with a color coding around whether they were blocked or whether they're just being monitored at this point in time. And then size indicates a rough estimate of intensity of the attack. The map's only so good, as I think most of you guys know, because we can only chase the origin so far back, but it is a good reference to see where the attacks are being launched from. The apples to apples comparison with most other WAF toolsets really starts on the Threat Entities tab. And on this tab, what you're seeing is of the 66 unique entities that are launching attacks, it looks like about 8 have actually made it to a blocking level. You'll see that there's quick references to the overall intensity, the risk level for that entity, and then we give the entities a pirate name and modifier, partially because it's easier for us to remember that entity, across multiple applications or across potentially multiple customers for our own SOC. But it's also because, as I mentioned before, sometimes the attacks are coming from multiple IPs. And in those cases, we will actually associate multiple IPs and all the attack traffic under a unique identifier, which to us is an entity. Quick reference then to the location. And for any one of these entities, you could drill down either on this page or virtually any page to get more information. So in this case, this entity, fairly simple. It's coming from the Netherlands. The user agent is quite unique. It's not a normal browser. No geo-reputation hit, which is one of the components we look at. The intensity, fairly low in this case. But as we look into it, what we're seeing is a various amount of scanning activity. If I jump into another one, say the Chinese version here, this one's kind of the same. Okay, here we have an example of an entity where you've got normal looking browser information, no geo-reputation hit. The intensity is starting to climb a little bit, but if we break it down, we can see these are the various attacks, web application mapping along with additional scanning activity, and there's enough of it as we drill into the details. There's enough activity against multiple URIs over a short enough period of time to cause it to get to a blocking state. So what's very interesting, and this is pretty common for most of the customers, is if you look at the various suspicious behavior that we're seeing, it's pretty common to see a smaller percentage that actually make it to their block level. And as I mentioned before, the key for our solution is we're trying to delay the blocking based on the risk until we've got enough information to either reach a point where they must be blocked, or they're getting deep enough in the kill chain that we actually want to block them at that point. Until they get there, we're going to delay the blocking because we want to see what they do next, both so that we can learn the patterns and the behavior that they're using, but also if it's a low enough risk, it may be something that is being caused by the application or something that development has done with the application, and therefore we want to continue to monitor it to make sure that it's not causing false positives. So a relatively standard profile will be for us to see somewhere in the neighborhood of 5 to 10% of all of the suspicious entities would make it to a blocking level. You're going to see somewhere in the neighborhood of 10 to 15% are going to be working their way up the risk profile. And then the rest of what you're going to see is typically the lower level noise. So things that are script kiddies, maybe botnet traffic, maybe just relative scanners and crawlers and things of that nature. But the key for our solution is we continue to track the traffic, and we continue to watch these entities and continue to append to their risk profile as we see them make additional progression. And so it really gets back to that kill chain approach that we talked about. Just the fact that a typical hacker will start out with some basic reconnaissance activity. They'll move on to the mapping to understand the URLs, and then they'll move on to identification of which URLs or which technologies are potentially vulnerable, and then they'll start the exploits. And so again, this is part of how the solution, or a major piece of how the solution for ThreatX works. We're looking for each of those steps, and then we continue to monitor and build our attack profile as we go. So threat entities, again, very analogous to this is how we go about identifying who should be blocked and then providing the information back to the customers so that they can understand how they were blocked and what they were targeting. Top targets is now where we take that information and we kind of flip it on its head. And this gets into what vulnerabilities or what components of the applications were the bad guys actually targeting. And so what you get is a list of the applications that are being monitored, and then you get the relative risk profile for them. And again, this one, a little bit different. This is a demo environment, so it's slightly different than what we would see for our customers. But a lot of times what we'll see is, the top 5 or 10 applications that they've been protecting with an alternate solution, and then they've also rolled on additional applications. Some of the applications they thought maybe were lower risk or maybe not being targeted. This is a great way for us to first and foremost be able to point out which of those applications are getting the most attention, the most suspicious traffic. And then for those applications, how do we start to zero in on which URIs are getting the most traffic and the most hits for those applications. And so, we would typically always expect to see the root directory or the home directory getting a lot of hits. But oftentimes what we'll see is there'll be another URI, a PHP file, or maybe it's just a content file. but it's something that's being saturated, and this is where our SOC typically kicks in, and we'll start to go and investigate those particular URIs to understand why are they getting as much traffic as they're getting. And then for those, particular, in this case, you're seeing certain types of exploitation attempts, SQL injection for this particular DMZ. And again, part of the way the solution works, and one of the things that it really addresses is the dynamic nature of application development, application deployment. So what this is allowing us to do is when there's a new code release that gets promoted to production, and maybe using one of the examples John mentioned, maybe it reverted a patch, and so that older version of code is being picked up. It's now being targeted. It's something that this portion of the application will start to identify. There's a larger number of requests or a larger number of entities banging on that particular set of URIs, and that's where the SOC will then swing in, start to investigate that information, and then reach back out to the customers to say, hey, it looks like you promoted code last night. Maybe you've reverted the patch. Maybe you've left indexing turned on, and therefore the mapping activity is going very high. The botnets are seeing that, they're picking that up, and they're putting you out there on the various list to be targeted. So we're seeing a large number of things, both vulnerabilities that could be picked up by a vulnerability scanner, but oftentimes the type of vulnerabilities that we're picking up here are vulnerabilities that are just being introduced by developers, shortcuts that we're taking, something that not necessarily is going to cause a vulnerability scanner to pick it up, but it's something certainly that as the bots pick it up, it starts to increase the traffic for that particular application. And then the last tab that I'll walk through, and this maybe kind of gets to some of what we're talking about from a kill chain approach. When on the diagram that I showed, any one of the sensors identifies any suspicious traffic, it's then going to classify that traffic as either reconnaissance, scanning, mapping, brute force, DDoS, exploitation, or malware communication. And then there's a sub-classification under each of these major categories that gets into the details of what is the specific type of attack going on. And so, as you can imagine, a particular entity can do a fair amount of activity at the reconnaissance level. That's lower risk, and therefore the tolerance for those entities is going to be higher as we continue to watch them do the reconnaissance. But as they start to step their way deeper into the kill chain, the risk goes up as you go more or less linearly down this path. And so as we see the progression, from reconnaissance, scanning, and mapping on into the various exploitation attempts, then they will very quickly move into the blocking scale. That's not to say, though, that someone that was in a, let's say a scanner that's just doing a tremendous amount of scanning won't get blocked. Obviously, it may be a lower increment of risk, but if they're doing it with a high intensity, or they're just abusing the application, trying to scrape information, it's going to move the risk up fairly quickly and get them into a block status. So these 4 tabs are basically how we define the attack surface for the applications, starting with just the threat entities and which are making it to the top, what are they specifically targeting, and then also from an attack states, if you want to zero in on exploitation and really drill into the exploitation attempts that were going on against the application. It's just a quick reference there. The second part to the solution then is really an Explorer view, and again, very similar format in terms of total request, a threat map, threat entities, targets, and attack states. But now we have up to 90 days worth of data stored in the application. So this is typically used more from a forensics perspective. If I go back and say, maybe last month on the 21st and 22nd, if I apply those results, then what it's going to do is really repaint the information for that time frame, and then it's going to allow me to go zero in on the 22nd and look specifically at what attacks were going on during that period of time. So again, this part of the application typically used more in a forensics capacity, more in conjunction with maybe another tool set, but allows you to say if there was something strange going on, I'm picking up in my SIM, or I'm picking it up in one of my other technologies, if I can look at the attack traffic coming towards the solution, that's what becomes important. So I guess maybe the last thing that I'll kind of wrap up this demo portion for now, at least, and then we can jump back in during the Q&A. But part of what kind of drove us to build the solution was merely the fact that most customers, because of just the complexity and the overall operational burden, it's very difficult to protect web applications. Layer 7 is not ports and protocols. It's every application technology known to man. And most customers have kind of the same complexity we had at VMC, which was maybe we had some primary technologies where we were able to try to introduce our best practices for development into their processes. But at the same time, we had just dozens of technologies, multiple legacy environments, multiple acquisitions where we'd inherited various applications and exposed properties. And so, having a consistent process where we could maintain the patch levels across all those different technologies, as well as train the developers to execute best practices across multiple teams distributed globally, just almost an impossible job. And so we built ThreatX, and we built the platform that we built here to say you really do need something that can be front-ended very, very quickly, something that would be deployed in minutes, something that can be tuned in hours, not weeks, and something that can be distributed across virtually any environment, but the visibility then to which of the applications are getting targeted the most, and which of the applications are we seeing that we thought maybe were low risk. But now we find out that attackers love to go after those edge applications. They know you're protecting the top 5 or 10%, but what they want to target is the applications that are sitting on the edge. Again, where it's not being monitored, it's not being patched, and it's still an opportunity to both gain credential information, DIA information, or potentially port access. And so really what we're trying to do with ThreatX is provide a very simple to deploy, simple to use application, but something that can be distributed across your entire application footprint, thereby giving you 100% visibility to that attack surface and a good kind of proxy for what type of attacks are you seeing and how much are you being targeted. So I think with that, I'm going to jump just back to maybe the last slide, and then we can open it up, I think, to Q&A. And yeah, so I mean, the last slide really is one of the things that we take pride in at ThreatX is we love to get the free trials going. We love to get into bake-offs because the type of visibility that we're able to give, through the application helps our customers immensely understand, the overall attack surface, the types of attacks they're seeing, the level of sophistication they're seeing, and also the level of vulnerabilities across the technologies that they have that are out there. So we highly encourage folks to move forward with the POC type of process. So. And with that, John, I think I'll turn it back to you for questions.
Okay. If you advance one slide, we'll go. There we go. Get our dummy question slide up. We got a number of questions here. Just a reminder, anybody else you have questions you want to add, enter them into the toolbar on the right-hand side. Let's see. Let me take this one first. Since you are sitting in front of the web applications, or essentially like a proxy, how do you affect page load time? And I'll add in for both, static apps and dynamic apps.
Sorry, on mute. Yeah, no, so, typical latencies are very low for our solution. 10 to 20 milliseconds is not uncommon. It's obviously a common question, just because anytime you're in line, those questions are going to come up. But we have a geographic footprint loaded across North America as well as Europe and across Asia. And in addition to that, if we are seeing certain performance issues, we can obviously deploy the on-prem sensor. In that case, it's actually sitting next to the application itself.
Okay, I had a question. Do you have any examples of how this solution works detecting suspicious behavior from offshore development centers, i.e. it's not necessarily web front end on the internet and attackers going after the app. It's a friendly offshore development center connected with developers going between apps and bad developers doing bad, almost insider attacks. Do you have any examples of being able to detect that kind of behavior?
Well, we're typically deployed, in front of the application and monitoring the either the APIs or the HTTP traffic that's flowing to the application. And we can obviously be deployed on internal applications. In addition to that, we're watching for the 401s, the 403s. So when we are seeing any kind of suspicious behavior, it's stuff that we will pick up and identify as unusual status codes. And again, especially as the intensity arises, the one thing that our SOC is doing is monitoring the top targets along with our customers, and really focusing in on where are we seeing the most unusual or suspicious behavior, and then how do we forensically go in almost from a pen test perspective ourselves and try to understand, are they being successful, and what techniques are they using, and how are they operating. So what I would say is, we haven't had a lot of customers deploy us in that, for their internal development teams yet. However, some of our larger customers are moving now beyond their external applications to their internal applications.
Okay, let's see. You mentioned bake-off, so we got a couple questions here asking you direct comparisons to competitors. In particular, one was on asking you how you differentiate from Encapsula, the other how you differentiate from Qualys in this market.
Yeah, I think for Qualys, for Encapsula, you can kind of go through most of the legacy type solutions out there. Again, they work off of a static rule, static signature principle, and they're great solutions for kind of what they do, but they cover about 70% of the problem, and it's primarily because you're forced to take a look at the signatures that they have, but also monitor the behavior of your applications. And you end up whitelisting out a fair number of the signatures just to ensure that you're not hitting the false positives. And that's the biggest differentiation for us between those solutions is we don't whitelist things out. We may downrate the risk because we know this application has that type of behavior, but we still track the behavior, but we also put that behavior in conjunction with other behaviors that we're seeing. And so that's why, when we get into various penetration tests, there's a couple of things that can happen. If the penetration test or if the customer's testing is purely based on, I've got a rack stack set of static signatures, and I just want to see if you pick up as many as Imperva, Qualys, Encapsula, you name it, then yeah, we're going to look pretty similar because you're just throwing the same stuff at it. If you get into a penetration test or a testing regimen where you've got real hackers or real penetration testers who are taking the normal steps where they have to go through the reconnaissance, they have to go through the steps that they do to identify what parts of the application can be exploited, then it's going to be a great bake-off for us because the pen testers as well as the customers, we're going to get be able to sit there and watch them crawl through the application. We get to watch them hitting against the URIs, and we get to identify where the application is identifying what techniques they're using as they're hitting the application. And I think that's why we get so excited about getting into these bake-offs because you're just not getting that same visibility to the attacks that you're getting with the others with our solution versus the other solutions.
All right, I'm going to reword this question a bit, but here's the basic question. So you mentioned false positives. Obviously, those are sort of killer events. One false positive can destroy our ability to use any security solution. And I think in the demo, you sort of showed events being tagged and later on sort of upgraded as more suspicious and eventually making blocking. How does that work? Is that a staff intensive? Are the customers people making those decisions? Is your algorithm making those decisions? Or your SOC analyst? How does that work where actions are, rather than block them early and create potential false positives, eventually blocking is turned on? How does that happen?
Yeah, so there's a couple of different answers to the question. I mean, first and foremost, we do have a fair amount of machine learning that is going through and baselining the applications themselves. And that's a key to why our false positive rate is low in the first place. But it's really the combination of the fact that, yeah, it takes more than one step typically to get into a blocking mode. And it's the fact that we're building this risk profile in real time on the fly as they progress, through multiple suspicious behaviors. Now, and the way you worded it, at least in that, I mean, there's nothing kills a security mandate faster than shutting down legitimate traffic. And that's why, we built this really to try to minimize the false positives. We all know some false positives may still happen. And that's where, when we're seeing certain things, our SOC absolutely is kind of monitoring along with our customers what we're seeing. And so they're always tuning in the background. But it's not super labor intensive. And I think the biggest differentiation is with the competitors, their SOCs are spending a lot of time trying to figure out how to write the signatures in the first place. What our SOC is working on is what's being targeted in the customer's applications, and how do we look at what's being targeted and ensure that our application is acting properly and it's not a false positive, and it doesn't need to be tweaked or tuned. And we do similar things. We monitor the Joomla boards, we monitor the WordPress boards, we monitor a lot of the various vulnerabilities that are being identified on a daily basis, and we test our application ahead of time to make sure that it picks up those type of vulnerabilities. But inevitably, you're going to see certain things that are making it through that are really zero-day type of activities. And again, that's where you want a SOC or a customer architect really digging into that information to understand, is it real or not real.
Whoops. And so how does that work? Is there some sort of alert? I'm the admin or the SOC analyst responsible for this area. I get an alert that you're recommending we enable blocking on this, or there's some thresholds I can set where anything that scores higher than this automatically move into blocking, or how does that work?
Yeah, so there's multiple configurations within the application itself. By default, the application blocks when it reaches a score of 70. So anything above a 70 will block. Now that's absolutely user configuration. There's another configuration, which is we typically block for 30 minutes, and then we unblock, and we see if they come back. And again, some of that is just for us to pick up additional intelligence on those entities themselves. But again, that's a customer configuration. Some customers want them blocked once and blacklisted, and some customers are, fine, continuing to gain intelligence on them as well.
All right. So say there is a false positive, eek, and you were going to stop blocking at 30 minutes, but I decide, we shouldn't be blocking this. I, as the analyst, can initiate unblocking, and then does that knowledge feed forward into you that, hey, wait a minute, that the customer turned blocking off, therefore we've got to lower the risk score if we see this again?
Yeah, so we could do a couple of different ways. Now we have an API and a CLI behind the scenes that customers can use to feed blacklist, whitelist, things of that nature in general. I've got the app, I think, still showing, so I'm going to jump in, just picking one of these guys. What you see is, as part of the detail here, you also get the current status. So in this case, it is watching. So you have the ability from this component within the application to go ahead and block, or move it to a blacklist, or move it to a whitelist. So in the case where, what you will get is typically, and again, it's a user configuration, but when we go to blocking mode, you're going to get an indication or a notification via email that this hushed Hawkins here was blocked. You're going to have to link back to the application so that you can actually do a very quick, let's check into it, let's see what they were going after, let's see the type of activity that they were doing, parameters, anything like that. So you get a really quick reference to why was that particular entity blocked. But if you want to go ahead and move it to the whitelist because it is a false positive, you can. And then we'll interact with our SOC typically to make sure that we understand why that should not have made it to a blocking condition. It's a fairly small occurrence, though. I'll just tell you that up front. We don't see a lot of false positives that require us to go back in and tune. However, what we do see fairly often is it may be your best customer, or it may be your customer that is getting blocked, but what's getting blocked is they've been compromised themselves. And so, their servers are actually launching the attack against your applications or your environment. And it's in those cases that a tool like this also helps, because we've been able to go for some of our customers and give them basically the same information here that you're seeing in the screen, so they can go work with their customers to identify what's being, what's causing the blocking condition, and help them actually get their systems remediated.
Okay, I had a question about deployment here. Do I, when I first get started, do I put this inline in sort of monitor learning mode, and then how long does it take to sort of learn and get to the point where I might want to start enable blocking? Or is there some other pre-configuration inventory things I have to do to configure?
Yeah, great question. So typically, we can run our POCs, and we typically have plenty of information within 2 weeks. So we're always targeting 2-week POCs, just simply because you will go with initial implementation. It'll be in non-blocking mode, but the scoring will occur so that you understand, which items made it to the level that they would have been blocked. Again, one of the things that we really like about this platform is it doesn't take weeks to tune it. So usually within 24 hours, what you see is what you get, and it's going to get better over the 2-week period of time. It's going to learn more and become even more accurate. But the reality is it's more of an accuracy in the overall scoring, not necessarily in who's getting blocked and who's not getting blocked. So definitely by the end of the 2 weeks, we will do a technical debrief with our customers. We're going to walk them through, here's all the data that's going to flow through over the 2 weeks. Here are the entities that were blocked. Here's the entities that were working their way up the list. These were some of the more sophisticated attacks, and this is how to use the application to kind of see that level of sophistication and what was occurring. And these are the vulnerabilities within your applications that are being targeted. And so at the end of 2 weeks, we usually have a mountain of information where we can demonstrate the value prop. And it's usually at the end of the 2 weeks where the customers are ready to move it into blocking mode. But yes, to answer the original question, it will go into analytics only mode during the POC just so customers can see it. If we're seeing something that's especially egregious, obviously our SOC will work with the customer. We may blacklist it just to keep that traffic out of the application, out of the customer's way.
Okay, we're just about at the end of our time period here, so I'll do one more question here. Question basically, we do annual pen testing. Outside of that, what is the best way you've seen to find vulnerabilities in our applications?
Yeah, I mean, and again, we do pen testing as a company as well, just because, basically we're building applications to stop the bad guys and stop really good pen testers. So, for us, above and beyond pen testing, and maybe some basic vulnerability management, it really gets back into this top targets component, because there's nothing better than, being able to have the metrics behind the vulnerabilities that are in the applications by able to point out, it's not just a vulnerability that we found, it's something that's definitely being targeted by the outside world. And with a WAF like ours, you have the vulnerability or the visibility to certain endpoints and certain vulnerabilities that, the typical pen tester just may not find, but it's something that the outside world has figured out, and therefore you've got complete visibility to that information. We see everything, we see all traffic, and we're looking at all their traffic, not just an individual transaction, but all their traffic, so that we can identify what looks suspicious and what are they trying to get to at the end.
Yeah, and I'll just throw in closing, since I showed you work I've done in this area since 2001. Finding web vulnerabilities is actually the easy part, but if you just spray the IT side with trouble tickets for literally thousands of vulnerabilities, that's another area where false positives cause everything to fall apart. The second thing is, if you can't prioritize them as to these are the vulnerabilities that have to be fixed right away, these are the most egregious ones, the ones most likely to be attacked, the ones most likely to cause major damage, then you never get the right ones fixed in time. So finding's easy, getting the right ones fixed in quickly is the hard part. Okay, with that, let's jump forward to the resource slide. I want to give you guys a list of some URLs where you can get additional information. I mentioned the CIS critical controls. You'll see a link up there for that. I do a program at SANS called What Works, which is where vendors give me customers of theirs to interview about how they decided or how they had a particular security or business problem, how they investigated the best solutions, deployed them, their lessons learned and all that. That's the What's Work program. SANS Fire is the next major SANS conference coming up here in Washington, D.C. soon, where you can see everybody, vendors, and also take SANS courses and attend the nighttime events that drill down into topics just like this one. There's ThreatX's URL for see their capabilities and get additional information from them. If you are watching a recorded version of this session, if you send your questions to q@sans.org, we'll get you additional information. So if we go to the next slide, I'll just turn it over to Carol for any final words.
All right, well, thank you so much, John and Brett, for your great presentation, and to ThreatX for sponsoring this webcast, which helps bring this content to the SANS community. To our audience, we greatly appreciate you listening in. For a schedule of all upcoming and archived SANS webcasts, including this one, please visit sans.org/webcasts. Until next time, take care, and we hope to have you back again for the next SANS webcast.